Hi, welcome to an Arduino step-by-step course by Robojax. In this lecture, we're going to introduce this Arduino development board called Digispark USB, and this is non-official Digispark micro USB. These are the development boards that you can use instead of this larger size Arduino board. Let's get started with them. These two boards are exactly the same in terms of size. The only difference is that this is plugged directly to USB of your computer like this, and this is a micro USB that you can plug in to your phone charger or any other micro USB cable that you have. You can see that in terms of size, this is 8 times smaller than this board. With reduced power and number of pins, in many applications they are suitable because most of the time you don't need the full power of this Arduino board, and also you do need a lot of pins. So this board can be replaced with this one, and for example, if you compare it to this relay module, this is the size. This is much smaller than relay module. These two are exactly the same, with the exception that this has micro USB and this is just USB, will directly be plugged in. But also we have another difference, that this 5 volt regulator on the module is capable of supplying 150 milliampere at 5 volts pin here, but this one has a larger with a bigger heatsink. This can supply up to 500 milliampere. So depending on your application, you just pick them up. Other than that, all the pin and everything else is the same. So in this lecture, I will be using this one and continuing with this. If you need fewer pins than Arduino Uno, this has 6 pins and some power reduction. This is suitable for tons of application. Arduino Uno is based on this chip, and this one we have a smaller chip, Attiny85. I'm going to show you how to prepare your Arduino IDE and then do some blank tests and how to start using this. This is the board, and these are the connection for USB, which you can insert it in your computer. When you purchase it, usually it's shipped with a pin header like this. We have to solder them here. For the 3 pins, we need the header with the 3. We just cut the 3 pieces. Then we solder the pins in here. I've now soldered this pin header. From here, pin 0 up to pin 5, we have 6 pins, and then we have 3 pins here. The pins are labeled here as VN, ground, and 5 volts. Then here we have a voltage regulator. The VN, you will connect it once you program this and take it for your application. There will not be a computer or connection. So either you will supply 5 volts via USB cable in here, or you can connect external power here. From here you can connect up to 16 volts. The 16 volts come here, goes to this 7805 voltage regulator that regulates it to 5 volts, that supplies power to this, and also you will be able to get 5 volts at this pin. Can supply up to 500 milliamperes from this pin, not more than that, so keep that in mind. And here are the pin outs. These are digital pin 0, 1, 2, 3, 4, 5. So when you are defining it in your Arduino, you just type 0 without D or anything. 0, 1, 2, 3 up to 5. These are the analog pins. Analog 0 is here and 1 is here, 2 and 3 in order. And also you can have analog reference. You can read this pin digital 0 can be used for analog reference. These 3 are pulse width modulation, where you can control servo motors and light or other application that need pulse width modulation signal as an output. We have 3 pins, 0, 1 and 4 are pulse width modulation. You cannot get pulse width modulation from the other pins. For I2C communication, majority of devices that need that communication of 2 pins SDA0 SCLS2. This is the SPI communication pin layout. The clock pin is digital 2, and then the clock pin, and these two are the in and out pins for SPI. We have two LEDs here. We have one power LED and one test LED. And here is the schematic diagram. As you can see, this is pin 0. We go pin 0, 1, 2, 3 up to 5. So pin 1 is the second pin which has connected this LED. If the status of this pin is high, the LED will turn on. So this LED is connected. So that LED is connected to pin 1, to this pin. The input pins have been also labeled here, but I will use the map. Here is a Digistamp page for this Digispark USB board. You can buy it from eBay by typing Digispark Attiny85 or just Digispark, and you will see the option, and it is sold here for $175, and you have to wait for 50 days to get it, maybe sometimes 70 days, or you can get it from Amazon as well for 12 bucks, 5 pieces, or maybe $9, different packages, 3. Or you can get it from AliExpress. It is sold for around $8 US. It can be connected via USB. We have 6 pins, but if you're using USB, the 2 will be used for the USB, otherwise 4 will be used. And we have 8 kilobytes flash memory, which after bootloader it will be 6 kilobytes. And we have I2C and SPI communication pins. And then we have 3 pins for pulse width modulation and 4 pins of analog. And we have LED, power LED and test LED. And here is the schematic diagram of the module. We have 2 chips. This is the 78M05. This is 5 volts voltage regulator that receives from VN and gives out 5 volts. That 5 volts is connected to everywhere that you see 5 volts, so which means they are connected. And also at this pin we also get 5 volts and ground at the 3-pin terminal in here with this 3 pins. And then the 6 pin that we have on the board, they are labeled. These 6 pins are labeled from pin 0 to pin 5 here. On the schematic they have been labeled from 1 to 6. So this is pin 0 and that is pin 5. We have one power LED which is connected to 5 volts with a resistor. It will turn on as soon as the power is established, and the other LED will turn on when this pin 1 of the board is high. When it is high, this will be turned on, so we can use for test purpose like blink or any other application that if you need this is already with a resistor. And for the USB we have 3 pins. The 2 pin of this chip which are connected to pin 3 and 4 of the board. The pin 3 and pin 4 are connected via these 2 resistor and Zener diodes. Will make the communication possible to be programmed via USB. Here are some of the specs that you might need. For example, active mode at 1 megahertz, 300 microampere, and power down mode 0.1 microampere. You can do power down. The pin outs, as you can see, the pin 1 is used for reset. If you want to reset it, pin 1. First click on File, Preferences, and under the Preferences we need to put this text. This is the path that it gets board information. http://digistamp.com/packages digistamp_index.json. I will provide this in the description, so you can just copy and paste it in your URL for this board purpose and click OK. Once you are done, click on Tools, Boards, and then Board Manager. Click on Board Manager, and here wait until this all is active, and then type DG. As soon as you type DG, DIGI, you will see Digistamp AVR boards. Now you see this is installed. If I click on this, you will see the remove appears. In your case, because you have not installed it, this will be installed. Click on that and it will take, maybe depending on your internet speed, 30 seconds, 1 or 2 minutes, and it will be installed. Once that is installed, then go to Tools, Boards, and then scroll down. Below the line, somewhere at the bottom, you will see a divider and you will see Digistamp AVR boards, the title and all the boards. In our case, we will select Digispark default 16.5 megahertz. Click on that, and as you can see, this have been now selected. The board is selected and your IDE is ready to accept Digispark board. Now to run a Blink test program, go to File, Examples, Basic, and open Blink. When you open Blink, this LED built-in is for Arduino Uno and other devices, and change it to pin 1, make it 1, and LED blink, make this 1, and make this 1. After that, click for the port. Do not worry what port is selected, and just click upload. This is not connected. Click upload. It compiles it first, and now here it says you have 60 seconds to upload. At this stage, insert it, and you will see the power is up, and you will see here uploading, and you will see done. Upload done, and as you can see, the blink has started. If you're new to Arduino, pin mode 1, this means set the pin 1 as output inside the setup, and then whatever code we have here, this will be executed continuously. This line says digital write, make digital pin 1 and send the signal as high, and then keep it for 1 second high, so that is when it is on. Then we say make digital pin 1 low. This makes it low or turns it off and keeps it for 1 second. After that, the loop continues, makes it on and off, and every time 1 second. As you can see, this is 1 second on and 1 second off. If you want to change it, let's say make it blink faster, let's make it 300 millisecond, and now let's remove it, compile the code, it says 60 seconds, and then once this is done, you will see now with the power that's running, it will be 1 second. Now it's started. As you can see, now it is blinking very quickly. We are going to see how we can open serial monitor or get debugging information with Digispark USB, Digispark micro USB, and other products. You can get the code for a serial monitor for Digispark by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Find a normal serial monitor with regular Arduino. You type inside the setup serial.begin, the baud rate 9600 baud or bit per second, and also then you type your text, serial parent, or also maybe inside a loop. After that, when you run the code, let me just connect it and run it. As usual, you just click. I am within the 60-second time frame, so connect it, wait for this until it says done. Now it's uploaded. If I open the serial monitor, nothing happens. This is COM3, and we don't have a defined and we don't have a defined serial port for this. For that reason it doesn't work, and we have to do it other ways. First thing, your system should have already with a built-in Digispark boards. If you click on boards and scroll down, you should see all of this. If you do not see all this, I have another video explaining how you get that. The link will be below the video in the description, or just click here to get it. The first line here, it says include digikeyboard.h. Once you installed all the boards, this is part of that. You don't have to worry, it is already included. This is a class, and we use different methods. First, delay 300,000, this gives it a little time, and then digikeyboard.println, we put our text this way. And I have put this, so when this program runs, it will print this line and this line. So to do that, first open your notepad. This is a notepad. You can also open Microsoft Word if you wish, or any other program that you can type. So this is my notepad ready. Your board is disconnected. Click upload. You will see the 60-second timeout window. Now I will connect this. Once I connect it, wait until you see it says done. As soon as you see done, click on the notepad and wait. When Digispark boots, it will print the text. So this is the text that has been printed in here. From this, we have printed in here. In the board, disconnect, connect. When this runs, the keyboard will print it in here. You see, it has been printed. Now, if you need to have something in the loop, the same way, you can put your code in the loop as well. But this will be like crazy. It continuously will print the code. First, let's disconnect, upload, wait for the 60 seconds window. When it says now it has been compiled, connect, wait for the upload done. Click here, and you will see that it will just print because it's a loop. Now, at this moment, if you click on your notepad, it will be printed on the notepad. If you go here, it will print it on Arduino, which I'm going to get back. To stop it, simply disconnect, and it will stop. Now undo, Control Z, so my code is clean. And you can do this the same way with your USB. Again, upload. Now 60 seconds, it says the window has appeared. Insert it and wait for this program to say done. Done, click, and it will print it for you. And anytime if there is a loop and the program runs printing, just disconnect it and it will stop. Show you how we can control AC bulb or DC load using Digispark USB development board, either this one or that one, to control it via a 5 volts relay. In many applications, you need to control a relay and also control an AC load or DC load. And using a large actual Arduino Uno or Arduino Mega will be a waste of money and space. And this is a perfect module that can do the job. Let me explain now this relay module. The relay module has 3 pins here. The first one is on this side labeled as N. This is for input, where it receives the signal. Then we have the ground. This will be connected to the ground of Arduino module. and this is VCC. This will be connected to 5 volts. We have also 2 LEDs here. This red LED will turn on when this receives power, and the other one, when it receives the signal, it will turn on. When this is turned on, your relay will be energized and the load that you have connected will be turned on. For this project, you can also use this relay. The connection for the terminals are exactly the same. Negative is on this side, positive is at the middle, and input has been labeled as S or signal or off. We have 3 terminals here, and as you can see, this is labeled in Chinese and this is labeled in English. This is normally closed. If you connect your 2 wires in here, they will be normally closed, meaning without any power or anything, this wire will be connected to this wire, and your light or bulb or power will be switched on. And for your application, for our application, we will be connecting it in this 2-1, which is called normally open. So this is normally open now, and when the relay is energized and receives signal and power, this will connect these 2 wires. The same way for this one, except the label is in Chinese. So make sure to understand this. Either when this relay is turned on, your power is disconnected or connected. In any case, you have to connect 1 wire at the middle, and the other wire should be moved there. If you connect it here, your load will be turned off if this is on, and if you connect it here, your load will be turned on. So this is most of the case people will need to control and turn on. Now let me explain the wiring. Word of warning: once this is connected to AC, do not touch the relay, because this is a hot area and it will be very dangerous. And also make sure do not leave this relay on a surface that is metallic or conductive. This is a tabletop AC bulb, and this is the plug that you plug it into the wall and the device will turn on and off. And I have cut one of the wires of this, twisted them and soldered them, and this will be connected to relay. And the job of relay is to connect this and turn on the light, and this connected to turn off the light. The 2 wires that I shown you will be connected for the AC bulb to these 2 pins of a relay. For the relay, this is N. The N is connected to the first pin of Arduino, the pin 0, and then this green is ground. Ground is connected to the middle of Arduino board or Digispark board, and this is a VCC or 5 volts, which is connected to the last pin of this board. And here is how you can calculate the power rating of a relay. For example, this relay has been rated at 10 ampere at 250 volts, 10 ampere at 125, and 10 ampere at 30 volts DC, and 28 volts DC. In all these voltages, it has been rated at 10 ampere. But this one has been rated at 10 ampere 250 volts AC, 15 ampere 125, and 10 ampere 250. Regardless of which module you have, they all have a rating on them written, so keep that in mind. And this is a tiny version, and this is a smaller version. It has been rated at 2 ampere 30 volts, 0.6 ampere 110 volts DC, or 0.5 ampere 125. For all of this, you can find the data sheet from manufacturer and read it. For example, in your region, if you're controlling an AC load and the voltage is 220 volts, 10 times 220, just put a 0, it will be 2200 watts or 2.2 kilowatts. And if you're in North America, if it's 125 volts, for example, this one is rated at 15 ampere. So 15 times 120, you will get 1800 watt or 1.8 kilowatts. If you're using, let's say, 12 volts and 10 ampere, just multiply 10 times 12 volts, it will be 120 watts. So keep that in mind. But this is smaller. This can handle 0.6 ampere. If the voltage in your region is 220 times 0.6 ampere that this can handle, it will be 132 watt maximum that this can handle. If you overload any relay with a more than rated current, it will melt and there will be a hazard of fire. And if you want to go the other way, let's say you know the power and the voltage and you want to calculate the current. Let's say you have 1500 watt power and your region is 220 volts, 220. This can handle 6.8 ampere. So if you're using this relay, it is rated at 10 ampere, you're good. Make sure that the current that you calculate is always below the rated current, or the power that you calculate is always below the rated calculated power. Let me now explain the code. We define pin 0 as a relay, we call it relay, and throughout the code we will use this text keyword relay to refer to pin 0. And inside the setup, which starts from here and here, we just use pin mode. Let me turn this off. And using pin mode, we define relay, which is pin 0, as output. Then inside the loop, which starts from here to here, this code will run continuously. And this is just an example. You will change it accordingly for your own purpose. And we use digital write, which writes voltage to the output of the Arduino. We use relay. That means as if I type 0 and low. This means send low signal to the relay. This relay is low trigger and it will be turned on when it receives 0 volts. So that's why we put low and then we keep it for 2 seconds. So this is not connected to AC. So this is turned on for 2 seconds and off for 1 second. Off is shorter. So we wait for 2 seconds and then we use digital write relay high. Now this pin 0 high, it will turn and off. So this and off will stay for 1 second. When this goes low, it waits for 2 seconds and turn off for 1 second, and the loop continues like that. We can change the time here. For example, if you want it for longer period or shorter, let's do it 300 milliseconds and then 300 milliseconds. Now to upload it, we have to disconnect our microcontroller and click upload. By the way, this works exactly the same with this one. For convenience, I'm using this one because the cable is easy for me. And we have 30 seconds window opened at this stage, connected. You will see upload done. And now it's 30 seconds, 300 milliseconds on, 300 milliseconds off. And for your application, if you want to turn it on, this is the on part. Let's say based on some action or something you want to turn it on. Here you can say if, let's say something, a temperature. If you have temperature, if temperature is bigger than 80 degrees, let's say this is a fan and you want to turn on a fan to cool up something. If the temperature is above 80 degrees Celsius, you want to turn this on. And after that, just close this and disregard this portion. I'm just showing you how to turn it on. If the temperature is above 80 degrees, the relay will be on. Else, you can say else, which means otherwise, turn it off. So this code will be there. So this way you can control your relay. In this video, I'm going to show you how you can find I2C address using I2C scanner with Digispark USB and Digispark micro USB development boards. Applications you need to find I2C address. I've written this on this one. I2C address is represented with hex value, and to understand if the value is hex, we just put 0x at the beginning. So this says that this number is hexadecimal value 3F. So you need to find the address for this one, and maybe for the other sensor or whatever. To run I2C scanner, there is some steps you have to take, and let me show you that one. Make sure that SDA and SCL are properly connected. On this module on the Digispark, The first one is SDA. As you can see here, this pin SDA have been labeled as SDA. This is connected to the first pin. This is digital 0, first pin, and SCL, the last one, will be connected one pin in between, so this is on the third pin. This is also labeled as digital pin 2, 0, 1, 2, so one in between SDA and SCL. So once the wiring is connected and this device needs to power up, connected to the ground and 5 volts, VCC is connected to 5 volts, ground is connected to the ground, then you're ready to read the connection is the same for this one as well. So first make sure that Digispark library and files are installed on your computer. I have another video explaining how to start with Digispark USB and micro USB. Make sure to watch that. After that, click on Tools, Boards, and from this window scroll down until you see Digistamp AVR boards, and the first one for these is the Digispark default 16.5 megahertz. This is selected. If not, click on it. That is done. Then go to File, Examples, and scroll down on here until you see examples for Digispark, and then go to Digispark Examples and click on I2C scanner. I'm putting it here, and then after that on the start menu type notepad, N-O-T. As soon as you type notepad you will get the notepad. If not, type full notepad, open it. I grab this from the top bar, the screen is at the middle. Now I'm bringing it on this side, click on upload. This is not connected now, neither this one nor this one, so the device is ready, connected in here but not connected. When you see it says that you have 60 seconds at this stage, connect it and wait until you see here it says done, upload done. When it says done, click here. As you can see, it prints the address for you. (0x3f) for this device. Another device, the larger one. Now I've connected another device which has a different address, 0x27. Let's check it. Upload. Click on upload. Not connected yet. We have the 60-second window open. Plug this in. When you see upload is done, immediately click here. Now this is the active window, and click here. 0x27. The address for this was discovered and printed. So what it does is that it prints on any screen that you have. If I have here Microsoft Word, if I open Microsoft Word, it will print on Microsoft Word. If you go on Arduino and click, it will print it on your Arduino. Of course, you don't want that. Now I've connected this VL53L0X. This is a laser distance meter that measures the distance, and let's find out the address for this one. I've connected SDA to this pin and SCL exactly the same way, and I've powered it up with 5 volts. Let's upload the code. First, do the same. We have 60-second window. Click. As soon as it says done, click on here. And as you can see, it shows 0x29. In this video, we are going to see how we can use this LCD screen with Digispark USB and Digispark micro USB with Arduino. The screen is called LCD1602 because it has 16 characters on each line, and we have 2 lines. So it's called 1602, and we're going to use it with the Digispark Attiny85 microcontroller. This is the USB version, which you inserted directly to USB, and this is the micro USB that will be connected via cable to the USB. In both cases, the code, pen, connectivity, and everything is the same, except when you connect it to the device, it will be different. The screen has I2C communication module here at this point, and we have 4 pins here. The whole board, we have 4 pins here. Ground, VCC, ground will be connected to ground, VCC will be connected to 5 volts. Then we have SDA and SCL, which I'm going to show you how to connect it. We have a jumper here at the back, and there is a light. This backlight will keep this lit. So if you remove this, the backlight will turn off. And also we have here this potentiometer. If you rotate this potentiometer, the intensity of light of the screen will change. You see, it become very bright and it become very light. At different angle, you get different brightness. And this module is offered in green, white, and blue. This is the green version. Here is the blue version. Now explain the wiring. From this side, the ground is yellow, have been connected to this ground, the middle pin of Digispark board. The VCC, the second pin from this side, have been connected to 5 volts with an orange wire. And then we have SDA. SDA, as you can see, is the red. The pin 0 is SDA, or pin 1. You can connect to the first pin, that's pin 0. And the last pin is SCL. You just leave 1 pin and go to the third pin. That is SCL. Let me now explain the code. First, to open the code, go to File, Example, scroll down until you see Digispark series of codes. So these are all examples for Digispark, and you will see Digispark LCD and Basic. Once you click on that, this file will open. The first thing that you have to do is put your address here. In my case, I found the address of this one to be 3F. You have to run I2C scanner to get address. Usually it's 0x, this 0 and x mean hexadecimal, and 3F is the value for hexadecimal. It can be 0x20, 0x27 usually, or 0x38. Click on Tools, Boards, and from this window scroll down until you see Digistamp AVR boards, and the first one for these is the Digispark default 16.5 megahertz. This is selected. If not, click on it. That is done. Then go to File, Examples, and scroll down on here until you see examples for Digispark, and then go to Digispark Examples and click on I2C scanner. I'm putting it here, and then after that on the start menu type Notepad, N-O-T. As soon as you type Notepad, you will get the Notepad. If not, type full Notepad. Open it. I grab this from the top bar. The screen is at the middle. Now I'm bringing it on this side. Click on Upload. This is not connected now. Neither this one nor this one. So the device is ready, connected in here, but not connected. When you see it says that you have 60 seconds at this stage, connect it. And wait until you see here it says done. Upload, done. When it says done, click here. As you can see, it prints the address for you. (0x3f) for this device. And this value goes in here. From here we define it and it's used here. 16 means we have 16 characters here, and this 2 means we have 2 lines. This is first line and second line. Inside the setup we use this tiny wire m.begin. This initializes the I2C communication. This initializes a screen. Backlight will turn on this backlight for us. And then this will print LCD.print, will print the text. This is the text that initially when you turn it on, it shows the text. Let me show you. So when it boots, that is the first text that you see. And it waits for 3 seconds and disappears. So this 3 seconds is to give you enough time to read that. Inside the loop, this code will run continuously, this portion of the code, because this is a loop. It will execute line by line, reaches to the end, and it goes back. At the beginning, we have to clear, because initially, remember, we had this text. We have to clear whatever is in a previous loop iteration. After that, we say lcd.print Robojax, that will print this text for us. Automatically it starts with character 0 if you do not set the cursor at the beginning. And then after this, now we want to print the text on the next line, so we say set cursor 0, 1. That 0 means character 0 and 1 means line 1. This is line 0, this is line 1. So we jump 1 line below and we print this text hello world up to exclamation mark, and then we wait 500 milliseconds. If you pay attention closely, it blinks every half a second because we go and replace the code with something else. So in your case, if you're reading a sensor or value from somewhere else, you can do your iteration here. So this was the example and how easy it is to display the text here. And it works exactly the same way if you use Digispark USB version that you plug in directly to USB. First, let's compile the code. And now I'm within the 60-second time frame. Wait for it to say that it is completed. As you can see, it works perfectly with that module as well as this module. Thank you for watching. This was how to use this LCD screen with Attiny85 Digispark USB development board.